Welcome to the first lab in the CCNA series where I attempt to blend my real world troubleshooting skills and bring that to the table and mix it in with those networking fundamentals that you are going to learn if you're studying for the CCNA or even if you're just beginning in your network engineering career. Before even touching any kind of Cisco switches and all of that stuff, I think that the most important thing for a network engineer to understand is how devices talk on a network. This means understanding IP addressing at a level that you can use the OSI layer model to reference it to troubleshoot communication issues between devices on a network. Today, in our first lab, that's what I'll be doing. I'll be walking you through and showing you how devices communicate or they talk on a network, as well as showing you how to troubleshoot it when they can't.
Let's start off by breaking down what you'll need for this lab. You'll need Cisco Packet Tracer, of course, and we'll be using just 2 PCs and 1 switch. This lab may seem basic and boring, but these are the fundamentals that you're really going to need when you're using real world network troubleshooting skills. You're going to have to rely on the fundamentals, and this is where it starts. Before we even get started, let's understand the concept of how the devices talk on the network. So just like every device on a network needs an IP address, so does every house needs a house address so that we can deliver packages between the source and the destination. Now, let's take a look at this same analogy, but with IP addresses instead of house addresses. Just as the previous slide showed us that we had 2 different addresses for our houses, we have 2 different IP addresses. However, the package didn't make it there. If you're still confused, let's take a closer look at this with a more practical example in our Packet Tracer lab. Let's begin by first setting up a simple, basic network. We'll need 2 PCs, so if you go here to your end devices, and we'll just click on a PC1 and we'll grab another PC for PC2. Next, click on any PC, we'll choose PC1 and go to the config tab, and then we're going to configure just a basic IP address. It'll be 192.168.1.10 with a /24 subnet mask. We're going to do the same over at PC2. You can definitely use different IP addresses in your lab. I'll be using 192.168.1.20 for PC2 in my lab. Now we'll go to the desktop and verify that the IP address is configured to what we configured it in Packet Tracer by using the IP config command. And as you can see, we do have the correct IP address that we configured in Packet Tracer. Congratulations, you've configured your first IP address. Now let's install the switch. To install the switch, navigate to the device tray and go to the devices and select switch from the list of the devices, and we're going to use a 2960 switch. Finally, all you have to do is connect the cables, and that's just switching to the connection type and selecting straight through cable, and just select whatever ports on the switch that you want to connect each of the PCs to. Remember that this is all layer 2. There's no routing for this communication, but this is perfect to understand communication at the next layer of layer 3, IP addressing. Let's test if these devices can communicate, because that's what we're here for. So on PC1 or PC2, just pull up a command prompt. Our ping is successful as expected, as you can see. But the CCNA isn't interested if you understand what ping is doing. They want you to understand of why it works. So let's look at this command arp-a that shows us layer 2 information. Running the arp command shows us the layer 2 MAC address information, which is important when you're taking the CCNA certification, because that's what they want you to know, as well as the employers that you're going to be working with this equipment on. When we take a look at the output of the IP config /all command, we can see that there is a different MAC address being listed. This is because this is the MAC address of the local machine, and we ping the remote machine. So we got the remote machine's MAC address information, and we have our own MAC address information here. That's how we know and verify that layer 2 is also working. Now, as a brief recap, we've verified that layer 3 is working by using the ping command, and we've verified that layer 2 has been working by using the arp-a command. Now that we have a clear example of what it looks like when our lab is working and how it looks when the devices are communicating properly, let's go into our lab and break the lab and see what devices look like when they can't communicate properly. All right, to start off, we'll verify the IP address again using ipconfig on PC2, and we see 192.168.1.20. Go to the config tab of PC2 and just change the IP address to 192.168.2.20. This puts the PC on a completely separate subnet than PC1. After making the change on the config tab, back on the command prompt of PC2, you can now see that the IP address has changed to 192.168.2.20 on a completely different subnet, and it can no longer communicate with PC1. Now, once you go back to command prompt of PC1 and we try to ping the IP address of PC2, remember we changed that to 2.20, no longer 1.20, we could see the failure happen. And now this might seem pretty basic, but this is real troubleshooting, and this is where troubleshooting begins. Because as you see the failures happening, we know what we did to break this lab. But when you're in the real world, you're not gonna know what broke whatever connection for the network. So you're gonna have to rely on those skills of checking layer 3 and checking layer 2. So again, let's run through those routine skills of verifying layer 3. Well, we see layer 3 is down. The next layer we have to verify is layer 2. And I gave you that command, which is arp-a. A quick check of layer 2, and we see that there's only an old ARP entry for the old IP address and not for the new IP address, indicating a layer 2 issue, which means we have to troubleshoot layer 1 and layer 2 of the device that owns that IP. In the real world, this is going to be happening all the time. People are going to be changing IP addresses, whether they fat finger it, do it on purpose, mistakenly do it, whatever the case may be, you're going to see a lot of it. And that's going to be the reason why you're going to have to learn how to log into a trouble ticketing system and work tickets. What you're seeing here is ServiceNow, and it's just a pretty standard wide industry standard ticketing system. And here's a demo just showing you how the tickets are laid out, just a basic layout and interface of the whole system. And then once you click on the ticket, it'll have fields for you to enter and put notes in. All right, before we get out of here, my goal is for anybody that's subscribed, anybody that's watching this, I want them to pass the CCNA. So just to give you a brief overview of what we covered today, we went over network fundamentals, a little bit of explaining the role and components of networks, like layer 2 and the switches, as well as configure and verifying IPv4 addressing, and a little bit of subnetting and private IP addressing when we use the private IP address for our lab. We also went pretty deep and verified IP parameters, especially that arp-a command, so we know what they're looking for when they want us to verify IP connectivity. We got a deeper understanding, and we learned that today as well. If you stuck around this long and you want to apply some of the skills and stuff that we learned today, definitely go ahead and try to fix the lab and make those devices talk on the network, because they're definitely not talking the way we left that lab. All right, so now you know how devices talk when they're on the same network. And way more important than that, we learn how to fix it when they don't talk and they're on the same exact network. But this is just scratching the surface of what you need to understand to have the CCNA. Imagine having to manage a network in an office building like this and having to have each PC have its own individual and isolated communication on the network. So for next week's video, we'll focus on layer 2 of the OSI model, which is switches, VLANs, and we'll try to take a peek into how real enterprise networks use VLANs to segment network traffic. If you're new here, make sure that you like the video and definitely subscribe so you don't miss any of my next upcoming videos in this series. If you're already in IT, I've got to ask, what's the first thing you check when a device goes down? Go ahead and drop it in the comments, because I want to learn from you too. I'll holla at you on the next video. Peace.